How's it going? My name is Esther Kim and welcome back. So today we're going to go over SAT math. We're going to do round 2 of exponential growth problems from Khan Academy. If you haven't checked out Khan Academy, definitely do so because it's a really great resource for SAT practice. So today's problems are really great because they definitely do test you on whether or not you understand exponential growth equations and also the basics of exponents because they test you on whether or not you know how to manipulate the exponents. So let's get started. So here's the first problem. Abhishek received an injection of a medication. The following expression shows the number of milligrams of medication left in his body after T hours. And then there's the equation. Half-life of a medicine refers to the amount of time it takes for half of the medicine to leave the body. What is the half-life in hours of Abhishek's medicine? The first thing we're going to do is take everything we learned from the first exponential video and dissect this equation. So 37 stands for the amount that you started with, which is 37 milligrams. The 0.25 is your rate. In this case, it's a reduction rate of 25%, meaning you're going to take whatever you started with and then reduce it to only 25%. And the number of times you're going to reduce it is in this exponent. So recall that this t over 16 should equal your total time over your rate time. So t would be your total time and 16 is your rate time, meaning that it takes you 16 hours to reduce whatever you started with to only 25%. But the problem is the question is not asking you for a quarter life reduction. It's asking you for half-life, meaning how long does it take for you to only have half of what you started with. So the equation that they want is something like this, like 37 and then 1/2 to indicate like a half-life and then to the power of the time that it takes you to do that. So we don't have this yet. So let's start with what we have. You have a 37. Let's change the 0.25 to fraction form. So let's say 1/4 to the power of t over 16. You realize that 1/4 is actually 1/2 times 1/2. So you can say 1/2 times 1/2 to the power of t over 16. But you also know that 1/2 times 1/2 is just 1/2 squared. So the 37 is not really relevant at this point. So you can say 1/2 squared all to the power of t over 16. So here's where they might be testing you on exponent rules. If you recall, exponents that are in parentheses, you should multiply them, meaning this should be 2 times t over 16. So then that would reduce to t over 8. So now your equation is 37 1/2 to the power of t over 8. And now this equation is in terms of a half-life, meaning you start off with 37 milligrams. Your rate is 1/2 and you have t to the power of 8, meaning that it takes you 8 hours to reduce to half of whatever you started with. Let's go on to the next problem. So let's review. Lucia posted a video of her cat playing on the piano. She found that the following expression modeled the total number of people who had viewed her video T days after she posted it. And then there's the equation. After how many days did the total number of people viewing the video double from the original number of people? Round to the nearest day. Okay, so the question is asking you to figure out when did the views double from the original amount, which means that they're testing you first to see if you actually can recognize what the original amount is from the equation. So if you don't know already, it's the 18. So you started with 18 views at time 0, and they want to know how long it takes for this 18 views to double. So you have to set this equation equal to 18 times 2, meaning like you want to figure out how long it took to double. So if you don't know already, when you have a number on both sides of the equation, they'll cancel out. So in this case, you have 18 on both sides, so 18 cancels out. And now we have the 16 to the power of whatever is equal to 2. 16 to the power of 0.0125t is equal to 2. One thing that's commonly tested on the SAT is whether or not you understand how to convert bases. So for example, on the right side, the base is 2, and on the left side, the base is 16. So 16 is actually 2 to the power of 4, and you can take all of this and take it to the power of 0.0125t and set it equal to 2. The second thing that they're testing you on here is whether or not you know what to do when you have powers in parentheses. So recall that you can actually multiply these two exponents. So then 4 times 0.0125 is actually 0.05. So in this case, we would have 2 to the power of 0.05 t is equal to 2. So one thing, this 2 on the right side is actually 2 to the power of 1. And that's really important to know because when the bases are the same, that means that the exponents have to equal each other. So in this case, we would have 0.05t is equal to 1. And then you can solve for t. So t is actually equal to 20 days. This is method 1, and it's more of the SAT style because they're asking you to manipulate the bases. I'm going to show you another method, which is just a little bit more mathematical. Okay, so here's method number 2. It basically starts out the same. So you have all of this and you set it equal to 18 times 2. The 18s will cancel out. And then this is what we're dealing with. We have 16 to the power of 0.125t is equal to 2. What you can do is actually take the log on both sides. And then recall that if you have a power and a log, this power actually can be taken to the outside. So you have 0.0125t times log of 16, which is equal to log of 2. Then divide the log 16 to both sides. And then you get 0.0125t is equal to, when you put this into your calculator, the right side, it should equal 0.025. Just a small note, this doesn't equal log 2 minus log 16, just in case you try to do that. You can't actually do that here. Okay, so getting back to the problem, solve for t by dividing each side by 0.0125. And then you'll get t is equal to 20 days again. So you have a couple options when you're trying to do this problem. So this one just uses logs. Let's try one more problem. Okay, so let's review. I'm going to read from paragraph 2 because it's super long. The following expression represents the concentration in microbubbles per milliliter of the microbubble suspension remaining in a client t seconds after the technician has begun the ultrasound process. Here's the equation. Which expression shows the multiple of the concentration remaining each minute as a constant or coefficient? Okay, so let's dissect the equation first. We have 100 million microbubbles to start with. The rate is 0.5, so it's being reduced by 50%. And the number of times you're going to do this is equal to t over 120. So t stands for the total time. 120 seconds is your rate time. So basically you're dropping by 50% every 120 seconds, which is also equal to 2 minutes. Question's actually asking you to calculate the concentration every minute. It doesn't mean that you have to change the number of times into minutes. You can still leave it as seconds, but it means that this t over 120 needs to look like something like t over 60, right? So t over 60 times 1 over 2 actually equals t over 120 because 60 times 2 is 120. So let's use that and put that into the equation. So we have 100, whatever, I don't care about that part right now. And we have 0.5 to the power of t over 60 times 1 over 2. I'm just going to move around the two terms t over 60 and 1 over 2 so that it's a little bit easier to see. So we have 0.5 to the power of 1/2 times t over 60. Recall that the power 1/2 actually means square root. So for example, we have 4 to the power of 1/2. That's actually equal to square root of 4. So in this case, we can take this and just write it as square root of 0.5 to the power of t over 60. And then we still have the 100 million right here that I'll now plug in. And that's the equation. So I hope you enjoyed this video. Feel free to like, subscribe, and comment below on anything you'd like to see in the future. Thank you.